Well, in my last tutorial, we were looking at wire. Today, we're going to be looking at connectors and plugs and how they have a crucial impact on the way that we build our projects. Now, before we start, let's just go to the warning. I don't work with power greater than 24 volts in my projects, and as such the connectors that we will be discussing are only suitable for low voltage. Do not use them on the mains, because if you do, you're going to electrocute yourself and probably have a fire. You've been warned. So that's the warning section over with. Let's get into the video. So here are a variety of connectors that I've laid out on my workbench. These are just some of the ones that I'm using in projects. You may have seen these type now and again. These are sort of a push fit. As you can see, they're pretty beefy. You could put quite a high ampage through them. We've got conventional 2.54 headers with the different pin types. Obviously a 90-degree one and a straight one. We use them very often for soldering into Veriboard. I've got some DIN connectors. These ones are 3-pin, but they come with everything up to 8-pin. We've got jack plugs. Down here we've got some crimp on connectors. These are the sort that you use on the end of servos. But you can build them up yourself with a crimping tool and the appropriate crimps. Down here I've got jack plugs, audio jack plugs. Now these can transfer quite a large ampage, quite important. Something else that we'll think about later as well, if I just pick this one up. If we look on the end of this, you'll see that there is a crimp that goes around the cable. You can literally clamp the cable in with this end section. That is important in certain situations, and we'll think about some of these situations later. Here we've got your typical screw connector. Obviously, again, they solder into Veriboard. I've also got this type. These are a much heavier industrial usage type, and you'll notice that they have a pattern on them that fits into the plug, and that means that you can't put them in the wrong order when you plug the two items together. Over here we have are they JST connectors, something like that? I love these connectors. I use them all the time. They come in a variety of pinouts. The only problem with them is that you have to use a crimping tool and obviously the appropriate crimps, and it can take a little bit of time to get used to using them. Now I'm going to add one other plug. I'm in the UK, so there's a mains plug. And you might think why I've put that on, and you'll see a little bit later when we start to look at risks why I've put that plug in there. Now I've had to revert to a photo because I can't do all the recording and hold everything at the same time, but we're going to go through some questions that you need to consider when you're looking at what plugs to use for your project. Now the first question is, how many amps are you going to be moving through the project? Very often we're only plugging in things that are measured in milliamps. In that case, any one of these connectors will work. But if you're using something like a stepper motor, or in my case I build a lot of stuff for model railways, some of my projects you're putting through 6, 7, 8 amps, maybe even up to 10 amps, at which point you start to have to think about what is going on. So that is a very important thing to think about. And as you look up each type of these connectors, you can sort of do a bit of research online, and you will find that each of these different connectors, just like wire has different ampage ratings, each of these types of connector has a different ampage rating, and it's important to make sure that you do not exceed the ratings for these different items. For instance, I think these DIN connectors, I think you can only put something like 2 amps through those. I know I can put 5 or 6 amps through these jack plugs, and I know that this orangey industrial connector will take some probably 12-13 amps. You know, they are pretty beefy, so that sort of thing is worth thinking about. The next question, and this might sound a strange one, is how many times is this item going to be plugged in and unplugged, and who by? Now that's an important one. So for instance, with a jack plug, let's be honest, most people are capable of plugging a jack plug in and out of the socket without causing any damage. And it's a pretty straightforward procedure, similar with a DIN plug. And you could probably, you know, they'll figure this one out as well. However, if we start to use this type of connector, because they have the sort of locking mechanism, similar with these ones, those can be a little bit difficult to undo. They're really a sort of a don't undo these all the time type thing. And so you just need to think from that perspective, who is plugging this thing in and how often is it going to be unplugged? Is this an easy unit to plug and unplug, or is it a difficult item? The next question to think to yourself is, what environment is this product running under? So I've built stuff for all sorts of projects, some industrial stuff, my own projects, but for instance, these type connectors that push in and sort of clip in, they are very, very useful if you've got a lot of vibration or stuff like that. These are going to hang in there. Whereas something like these headers and even these little plugs, if you have a lot of vibration, there is a chance that they will come loose. Now, there are times, for instance, with a servo, they come with that fitting. Now, if you're really worried about them coming loose in that situation, then it might be worth putting a little bit of hot glue on the socket just to hold the plug in place. But vibration is an important thing to think about. Is there dust? Is there water? You know, I've built a bagging machine and there's dust all over the place. Depending on what type of dust it is, can have a huge effect. There are waterproof connectors. You know, what's the temperature like? If you are concerned about these things, and these are worth thinking about, try and think of a product that works in the same environment and try and have a look and think, okay, what plug connector are they using for that particular item? Now, another question that you've got to ask yourself is, does polarity matter? Now, there are certain items where polarity is crucial, and a particular warning here is for LiPo batteries. If you watch the news, you'll see the odd Tesla going up in flames, and you'll see electric bikes and scooters blowing up. But one of the things to be aware of is, with a LiPo battery, if you wire it up incorrectly and short it, you also can cause an explosion. So for instance, if you've got a LiPo battery, I wouldn't advise using this type of connector, because even though they're color coded, an idiot can plug them in the wrong way, and idiots are ingenious. So think about sort of how that's going to happen. You may have to use a sort of a jack plug like this. It's just something to think about as you're looking at connectors. What is the environment? What's going to be happening? And what are the risks? Because one of the things we need to think about is what I call fail safe. Now, fail safe is making sure that either things cannot go wrong, or when they do go wrong, they don't cause any damage. I had a young man contact me about a particular project. He wanted to have a system on his motorbike that put a bar through the front wheel if the correct code had been entered through a keypad. As I pointed out to him, it meant that if the plug fell off and the unit lost power the way he designed it, it would immediately shove a bar through his front wheel, which if you're going along at 60 mile an hour is not a good way for the project to fail. So when I talk about fail safe, it's making sure that when things go wrong, they go wrong the right way. Now, this is a board for an industrial project that I did for a bagging machine. Now, on this one, you'll see there is a 4-pin connector here. This unit runs in a vibration situation, so that's why it's got these sort of locking plugs. You'll notice this plug and this plug have an identical pinout, but both of these are serial items. One goes to a touch screen, one goes to a set of scales. If you plugged the wrong plug in, the screen won't work, or you won't get the reading from the scales. However, because it's just serial communication, it will not cause any damage. Now, if we look here, we've got a foot switch, and this is basically 2 wires that go out to a switch. If that switch unit has to be replaced, it doesn't matter which way round they put the 2 wires in. It doesn't matter. It just won't affect anything. So I'm not worried about the polarity on that switch. However, here we have a power input. Now you'll notice this particular unit, it's a very strange unit. It has to have 5 volts, 8 volts, 7 volts and a ground. And you can't quite see it under there, but that is a 5-pin connector, and I've only got 4 items. The reason I used a 5-pin connector is I've already used a 4-pin connector. If someone plugged this plug into that port, then it would be a really bad day. Things could start to go wrong. I could destroy components. So that is why this plug, although it only needs 4 pins, is using a 5-pin plug. You'll see here there is a brake relay and a clutch relay. Now, both of these relays only require 2 pins. Again, this one's got a 2-pin connector, this one's got a 3-pin connector, because if I got these items back to front, it would be catastrophic on this machine. It would just literally tear itself apart. So from a fail-safe point of view, as we look at this board, you'll see a 2-pin, a 3-pin, 2 4-pins that won't blow up if they get plugged in the wrong way, a 5-pin and a 2-pin that, again, it had to be that size because this is a foot switch and it's a really thick cable that comes up from the foot switch. So this is just one example of what I would call fail-safe plugs and connectors on the board. Now, the next thing to think about is what I would, in the fail-safe range, is am I using the expected voltage for the item? Now, let's take a look at this mains plug. Great big thing. I could put 5 volts through that. I could put the socket, the similar thing, with 5 volts, and that would work very, very well. I'd be able to plug it in and out over and over again. However, from a fail-safe point of view, it's an absolute disaster. Because if I've got a 5-volt project, even though that plug is more than capable of handling the 5 volts, the issue is that anyone looking at this is expecting it to be something that plugs into the mains. So what are they going to do with my 5-volt project? They're going to plug it into the mains and they're going to blow it up. So this is one of these things when you think about fail-safe, are you using the voltage that is expected on certain items? Now, hopefully you wouldn't be stupid enough to use a plug like that, but these are USB connectors. I've got a USB-C, and just the good old-fashioned, is it USB 1, I think? I forget the name of it now. Anyway, one of the things with USB is they expect 5 volts to be going through them. So if you're using these in your projects, and I use a lot of USB connectors, make sure that you are only building circuits that are expecting and using 5 volts, because otherwise, from a fail-safe point of view, if suddenly you decide you're going to run something that can only take 3 volts and you know that that works on your system, don't start crying when someone plugs 5 volts into your project. So are you using a connector, certain connectors people expect a certain type of voltage, and stick to that voltage?
Now, the next question we need to ask ourselves is there a danger of the wires being pulled out? Now, this is a jack plug connection. This is part of a model railway project. So I've got a jack plug and a DIN socket. Both of these plugs have crimps that go into the end of the cable, into the insulation, so that it becomes far more difficult to pull the cable out of the plug. It actually takes a huge amount of force. But something else for you to think about, if you notice where this comes through the front panel, I've actually got a 3D printed insert that goes in that stops the cable touching the, if you like, the rough edges of the wood inside. Again, this is just one of those things just to make sure that over time the cables don't get worn through. Not that they're likely to, those are mains cables. That's why I chose them. Now, on the inside of this particular project, so you can see this is where the connectors are going out into these 2 plugs up here. You can see where the cables are now coming out through the 2 holes, but notice these cable straps. And there's also cable straps on the other cables. These are there so that if someone pulls on this cable, the strap will take the strain rather than it pulling on the screw connectors, because then of course the danger is that if you were constantly waggling this bit of cable, that connector is going to come off. So any strain takes place up here, and most of that strain will be absorbed by the outer insulation. So these are all things to consider when you are building your project.
Now, coming back to the workbench, this is a project that I'm currently working on. Again, bits for a model railway. But one of the issues that you can have, if you look here, is the danger of wires shorting out. Now, on this particular connector, it will be plugged in and plugged out a couple of times. Not many, but a few. And if you notice, I've put some shrink wrap tubing around the connector just to make sure that there is no risk of short circuit. Again, especially when you're working around LiPo batteries and stuff like that, that can be a very serious issue. I'm not so worried on these green cables that are all coming up next to each other, because actually they're all attached to LEDs and it wouldn't matter if one of them touch the item next to it. Just looking at the project board next to it, there is a DF mini player here that plugs into this socket over here. Now, it's pretty difficult to work out which way the player goes in. I'd have to turn the board over to see which way the wiring is, but I'm not particularly worried about it, because once that DF player is put in place, and I do know which way it goes in anyway, it'll be staying there. So it can be unplugged, the same as the ESP32 on this one can be unplugged from its header. So, you know, that is a connector, but it's not going to be done very often. Whereas here you'll notice, you know, the dreaded red nail varnish is over the connector. That is the 5 volt positive input to the board. Obviously the other side is the ground. Now, When we look at these connectors, again, my favorite little connectors, all of those have exactly the same pin out, because actually under the board, terrible soldering there, they're all connected to each other anyway, because they run on I²C, so there is no order to them. Whereas you'll notice down here, yet again, I have a 3-pin and a 2-pin connector, even though both of these items from what only require 2 pins. Again, that was to make sure that I didn't plug the wrong item into the wrong port. So this is a sort of typical project for me. One thing about these connectors, and I really like these connectors. When you're buying them, I would advise you, he says, reaching down, to buy a kit like this. Now, when you buy the kit, what is important is the crimping tool comes with it. You might think, well, I could buy it separately. Watch this. There are 2 crimping tools on my desk. One is for this type of crimp, one is for this type of crimp, and they are very, very difficult to tell apart. I know that because I saved money on my first set of those connectors, and I bought the crimping tool separately. I bought that crimping tool for these crimps because it doesn't work. Couldn't figure out, spent hours scratching my head as to why I couldn't put these connectors together. Then I bought a kit with the crimping tool in it, and all of a sudden everything worked. So just one of those things just to be aware of if you do want to use these connectors, and they are very, very good connectors. They are a standard 2.54 millimeter pin spacing, so they fit in Vero board very, very nicely. One other thing, as we look at these type of connectors, hang on, he says looking for the, there we go. So if we look at these header connectors will stick together pretty well. Let's face it, Arduino shields use these, but if you've only got, say, 3 or 4 pins going through, it is possible for them to go loose. At that point, that's where I'd say to you, if it's not something that's going to be unplugged very often, just put a bit of hot glue on there. You can always peel it off later, but it will hold them in place. So again, these are all things to think about when we're putting connectors on our projects.
So I hope that's been useful to you, and there is a link below the video to the Digital Town website where those various questions and considerations are all listed. One other thing that I just want to end with, again, a little bit of a safety thing. Your wiring and your connectors on your project should never get hot. Being blunt, they shouldn't even get warm. So if any of your connectors are starting to get warm, you can pretty much bet your bottom dollar that you are putting too many amps through the wire or the connector. Get yourself a bigger connector, get yourself some heavier duty wire, because that is how fires are caused. So just a little safety thing to end with. And again, whatever the situation that you're trying to get round, there are connectors for it. I've got a project that I'm working on at the moment that is actually going to be submerged in water the entire time. It's a pump project. There are connectors out there that are fully waterproof, and my project will not have a problem. So for whatever situation you have, there are connectors to do the job. It just takes a little bit of searching and some research. For that, Google is your friend. Anyway, bye for now, and if it's been helpful, please click the like and subscribe. Bye for now.